All right, let's get right into it. Today, we're going to break down a key concept in distributed systems, one that's super important for you to nail down for your exams, the load sharing approach. So, here's how we're going to tackle this. First, we'll cover what load sharing actually is. Then, we'll see how it works its magic, look at the 4 policies that run the whole show, and weigh the good with the bad. And of course, we'll wrap it all up with a solid, exam-ready summary and a neat little memory trick to lock it all in. Okay, so first things first, what exactly are we talking about when we say load sharing? Think of it like a team project. Load sharing is basically a strategy to make sure no single computer or node gets stuck doing all the work while the others are just, sitting around doing nothing. The whole point is to distribute the workload evenly to make the entire system run faster and more smoothly. You might be wondering, why is this even a problem? Can't each computer just handle the tasks it's given? Well, let's look at a pretty common scenario to see why that doesn't always work out. Imagine you have a system with 3 nodes. As you can see here, node A is absolutely swamped. It's got 10 tasks to deal with. Node B is doing okay. But then look at node C. It's barely doing anything with just 2 tasks. This is a classic bottleneck. Node A is struggling to keep up, and all that processing power in node C is just going to waste. And this is exactly where load sharing steps in to save the day. So how does it actually fix this mess? Let's walk through the process. It's really a simple 3-step process. First, the system is constantly keeping tabs on how busy every node is. It's the lookout. Second, it spots the problem. It sees that node A is drowning in work and node C is free. And third, it takes action. It says, hey, node A, let's move some of your work over to node C. And here's the result. After load sharing kicks in, a few tasks have been moved from node A over to node C. And just like that, they're both handling a balanced workload of 6 tasks. The whole system becomes way more efficient, and everything gets done faster. It's a win-win situation. Now, this transfer process doesn't just happen randomly. It's all managed by a set of very specific rules, or what we call policies, that make all the important decisions behind the scenes. For this whole thing to work properly, the system needs a way to answer 4 fundamental questions. You can think of these policies as the brain of the load sharing system. First up is the load information policy. This is all about gathering intel. It decides how the system is going to figure out who's busy and who's not. Will it poll each node? Will there be a central server collecting data? This policy sets the foundation for everything else. Next, you have the transfer policy. This one is the trigger. It decides when it's time to actually move a task. It basically sets a threshold. So if a node's workload goes above a certain point, this policy says, okay, we're officially overloaded, time to make a move. So we know a node is overloaded and it's time to transfer something. But what do we transfer? That's where the selection policy comes in. It has the job of choosing which specific task or process is the best one to move. Maybe it's a brand new task or one that's easy to relocate. And last but not least, we have the location policy. This one is the matchmaker. Once a task has been selected for transfer, this policy scans the network to find the best new home for it. It identifies which underloaded node is ready and waiting to take on the new work. So this all sounds pretty amazing, right? For the most part, it is. But like with any solution in engineering, there are always trade-offs. So let's quickly look at the pros and cons. When you look at the advantages, they're pretty clear. You get a big boost in system performance, things get done faster, and you're making much better use of all your available resources. It's a great way to stop parts of your system from getting overwhelmed. But it's not a free ride. All this coordination creates extra network traffic, which we call communication overhead. The system also has to be monitored constantly, and that takes up resources. Plus, moving a task isn't instant. There can be a small delay. All right, let's boil this all down. If you see a question on load sharing in your exam, asking for a 5 or 10 mark explanation, here is the key stuff you need to hit. So here's your summary. The load sharing approach is a vital technique in distributed systems designed to improve efficiency and resource utilization. It achieves this by moving tasks from overloaded nodes to lightly loaded ones. This entire process is intelligently managed by 4 key policies. The ones that handle how to get load information, when to transfer, which task to select, and where to find a new location. And to make absolutely sure you don't forget those 4 critical policies, especially when you're in the middle of an exam, I've got a super simple memory trick for you. Just remember the acronym LTSL. That's L for load information, T for transfer, S for selection, and the final L for location. LTSL. Burn that into your brain. It's a quick and easy way to recall the 4 pillars of any load sharing system. Keep that handy and you'll be good to go.